So for recording purposes, today is logs part 2. And we're going to jump straight into a question. Everyone take down the question, and I'm going to give you a jump start on it. Okay? A jump start on this question. Last week, I showed you all this, right? I just make it up my own example because I want to give away too much here. Last week, I showed you all that if you have two logs, exactly one log on each side of the equal sign, exactly one. Last week, I made it super clear. It only works for 1 and 1. If the bases are the same, like I had log 7 here and I had log 7 here, then I had like x plus 2 here. And let me just say I had 8, just 8, right? It doesn't matter too much. Last week, I indicated that in a situation like this, the logs would cancel out, okay? Leaving you only with what? X plus 2 is equal to 8. How much of you all remember that? That when you have exactly two logs, well, two logs, one on each side with the same exact base, you're allowed to cancel out the logs. It's like a real neat shortcut. Quick question. Can I use that in this question, in the official question 6? Is it okay to cancel out log 2 and log 2 here? I think you all remember from last week, the answer to that question is no. For this to work, I also indicated in front of the logs must be squeaky clean and must have nothing here and nothing here. And only then you could do what? Cancel it out. You would see that in this question here, there's this annoying tree. So we have to get rid of that tree using rule, ironically, number 3. Rule number 3 from last week said that if you have something in front here and you don't like it, like it's hindering progress, you could throw it over here and it will become what? A power. So that tree can move to that position first, and now you could start off the question. In other words, you can cancel out the log. So this log 2 can now cancel out with that log 2, and you will end up with x cubed is equal to 3x minus 2. You all need, the aim of the question is to solve for x, by the way. I didn't write it in, but obviously that's the aim of the question. Is this a quadratic? Can you all solve that? Is that a quadratic? Nah, it's not a quadratic. Remember, this is a remainder and factor theorem question. So this is one of the first, see how it started off as a logs, and now it ended up as a solve for x, as a remainder and factor theorem question. So what you have to do is throw everybody on the same side first, right? You're going to get x cubed plus 3x. No, not plus 3x. You throw across positive 3x. Oops. You get minus 3x minus 2 becomes positive 2 is equal to what? 0. Do you all remember how to solve but I used to call these quadratics, but that's not the real name, but that was my nickname for this. Remember to solve when you're solving a quadratic, you just normally get 3 answers. You all remember you're supposed to guess the first answer. You're supposed to guess the value of x that will equal it to 0. Anybody wants to help me with the guess? I think you can do this in your head. What value of x will make this entire expression 0? You can do it in your head. If you replace x with what? 1, correct? No, not 0. If you replace it with 1, think about it. If x is 1, 1 cubed is 1. So you end up with 1 here. Minus 3 by 1 is minus 3 plus 2. If you work this out, you're going to get what? 0. So that means the first solution, we always guess it. So the first solution is x is equal to 1. We have 2 more solutions to get, right? To get the other two solutions, remember, you have to divide this out. Oh, let me see something here. Oops, sorry. 1 second here. Right. To get the other two solutions, we have to, no, I have to make the assumption to remember at least what, Zachary, is sure? I think we'll get zero, you know. 1 minus 3 plus 2 is 0, not minus 4. Just check it back there. 1 minus 3 plus 2 is 0. Right. So to get the other two answers, we're supposed to divide this expression, x cubed, but you notice it have no x squared. So when I was teaching this topic, if it have no x squared, you're supposed to put in 0x squared minus 3x plus 2. And you are supposed to divide it by x. You take your first solution and you put the opposite of it. So since our first solution is positive 1, we are going to divide it by x minus 1. And when we take this expression and divide it by x minus 1, we're going to get what on top? A quadratic. And you are supposed, right? You're supposed to solve the quadratic. Get started, guys. So I hope turn back in your notes from since last term, right? Divide that expression by x minus 1. Obviously, I'm not going to be able to revise this entire topic at this point in time, right? We passed it so long in time, right? So divide it, get your quadratic, solve the quadratic, and send me your next two answers to make all the answers free, people. Right? So x into x cubed is x squared. Take the x squared and multiply it by both of them. X cubed minus x squared, minus in both of them. X cubed minus x cubed is supposed to give you 0, right? So like if you got 0 here, you're on the right track. 0 minus x squared. A minus and a minus is a plus, so you get positive x squared. And then you bring down who? Mr. minus 3x. X into x squared is x. Multiply both of them by x. So x by x is x squared. X by minus 1 is minus 1x. We have to minus both of them. X squared minus x squared is 0. You're supposed to get 0. That means you're on the right track. Minus 3 minus minus 1. 2 minus make a positive. Minus plus 1 minus 3 plus 1 is minus 2x. Bring down positive 2. X into minus 2 is minus 2x is minus 2. Multiply both of them here. Minus, you'll get minus 2x plus 2. And when you minus them, everything going to boil down to 0. So this is your quadratic now. So solve this quadratic on top and you will get 2 more answers. I await the other two answers. Quadratic is supposed to get 1 and minus 2. The 2 is the minus. The 1 is supposed to be positive. Right? Right. So make sure you see it, right? So I just want to point out once again, you can see our regular boring logs question just turned into a remainder and factor theorem question, which is pretty popular in the exam, right? So everyone has about 30 seconds. Again, just look for your mistakes and we will be moving on. Right. All right, so I guess that was a moderately hard question in my books. To me, that question was a moderately hard question. All right, so here's what everyone gets to pick 3 letters. I wish you the best of luck. Hope you get plenty gems of your team color. Okay. Don't worry, guys. Every class I change up the gems order, so it's not the same thing as last week. I won't do that. All right. So those are the gems there. I hope you got plenty of your color. And if you didn't get any, don't worry. If you look at the soldiers to the right, they said they found one red and two green gems on the ground. So I hope that helps you all further. Huh? People are saying, oh my God. All right. All right, so here's another question, right? It looks a little bit harder. From just looking at it, can you cancel out the logs? I know I showed you this trick last week, but you need to know. Can you cancel out the logs? The answer is still no, right? I know it have exactly one log on this side and one log, but it have this annoying number one here. The rule, I mean, if I scratch off this one and that wasn't there, fine. Yeah, the perfect case to cancel out the logs. So unfortunately, you cannot cancel out the logs. We're going to have to find a different way around this question. Right, so let me give you a little jump start on this. I am going to end up using rule number 2. So you're probably wondering, how are we going to use rule number 2? Rule number 2 says something about a minus sign. If you have two logs and you're minusing them, and they have the same basis, you can divide the quantities of the logs. So the obvious thing that I'm hinting at here is I can take this positive log 3x plus 2 and throw him across on the other side. And the positive will become what? Negative, right? So let me write that there. Log 3x squared plus 2. Remember, throwing this across on the other side, it will become minus log 3x plus 2. And now it's equal to 4 Mr. 1, because he's the only one on that side now. Everyone take them up to there, right? Well, actually, take a shot at it now, right? Using rule 2 now, see if you can finish off the question, right? Right. Oopsie, that's not one. So what we said here is that, what color should I use? I use a blue here. So we're using rule 2. So it have two logs with the same bases and they have a minus sign. So this whole expression here can be simplified to what? It can be simplified. Oh, they're a good color that can show. I'll just use white, right? So it will be simplified to log 3. Take the first value, this is x squared plus 2, and it gets divided by the second value, x plus 2, right? And this whole thing is equal to 1. Couldn't we convert this to normal form now? Y'all remember how to convert it to normal form? You say 3 to the power 1 is equal to this jumble here. How much of y'all did it like that? And I know somebody's going to say that there's a second way of doing it, right? But let me just keep it simple. Let's say, I know some people are saying you can use rule 5 over here to also get it out, right? But I don't want to do nothing too fancy. So you could say 3 to the power 1 is equal to that, right? The other way is this. isn't 1 the same thing as log A to base A once these two things are the same? So you could say 1 is the same thing as 1 multiplied by log 3, right? I don't want to go through all that. To me, it's going to be, it's going to confuse a lot of people, especially if you're brand new to logs. That to me, once I reach this point, it's just it's so easy just to convert it to exponent form, regular boring form. So you say 3 to the power 1 is equal to this. So 3 to the power 1 is equal to x squared plus 2 divided by x plus 2. And remember, 3 to the power 1 is 3. And you can just simply cross multiply now and solve for x. You will get a quadratic equation. So I'm going when you cross multiplying, if you want to have the same working as me, cross multiply the yellow diagonal first. Right? So cross multiply, you will get a quadratic. Just solve the quadratic and you're good to go. Cross multiply. Hope you got this for the quadratic. X squared plus 2. Well, anything multiplied by 1 is itself. And then you multiply everyone here by 3. 3 by x is 3x, and 3 by 2 is 6. So you get 3x plus 2. So you throw everybody on the same side. You will get x squared plus 2 minus 3x minus, well, this turned out to be a little easy, it's a real easy quadratic because the 2 minus 2 will cancel out, right? So you get x squared minus 3x is equal to what? 0. I don't even think you need to use the quadratic equation. And you can just factorize out the x and you'll get x minus 3 is equal to 0. And what you do now, just put each bracket equal to 0 and solve for x. So what are the two values for x? Right? Sorry, I did something wrong. Somebody, oh yes, I did something wrong. I did something wrong. Thank you for pulling off my socks. Nonsense. I just said that 3 by 2 is 6, and I put 2. So I guess we will end up using the quadratic equation. I'm supposed to have a 6 here. So I did make a mistake, right? If we do this now, we're going to get x squared plus 2 minus 3x minus 6, because we throw everybody on that side. And if we simplify, we get the quadratic x squared minus 3x minus 4. Correct now, guys? And all you have to do is solve that quadratic. So when you solve this quadratic, obviously you're going to get two answers, right? You're going to get 4 and minus 1. Those are your two final answers for it. 4 and minus 1. Right, so once again, it started off as a logs questions and using the rules and boiled down to a quadratic. Ah, you deserve a little break there. All right, so here's it have 4 letters. It have some preference, some people get preference here. The yellow and black team gets to pick 2 letters. So yellow and black, you're real lucky this round. Every other team, unfortunately, only gets 1. So follow the instructions, guys. Right? Let me know what letter or letters you are picking. If I had to choose a character here, I would either go with the green or the black. It seems like the two coolest characters. Right. Skeleton says, good luck. A. Those are the gems in A. Those are the gems in B. Those are the gems in C. Let's see what's going on in D. Some people are going to be happy. Some people are going to be angry. Right, so count up all the gems. Let me know how much you got in all. All right, so how about this one here? Just by looking at this one, which rule are you obviously going to end up using? Which rule? Isn't it almost the same format as yeah, it's rule 2 again, right? It's almost the same format, right? You just have to throw this across on the other side and it will become a minus, and then you can use rule 2. And then you put it in normal form, right? So see if you can speed up this question. Let's see how fast you can do this question. Most likely it's just going to boil down to a quadratic. Again, I guess I put this question in just to, you know, to make you practice what you just learned. Good luck. And let me see if I can time you guys. In the exam, literally, you're only going to have 5 minutes to work out this question. So I'm going to time you all, and I'm going to see how much of you all can produce an answer in 5 minutes. Good luck. All right. So like I said here, you're going to throw across this positive on this side. Let's keep it simple. I know there are more than one ways to get out the question, right? You show a teacher, there's like 3 different or 4 different teachers that might show you 4 different methods, huh? Right? So you're going to see that I'm going to try to just stick to one method, because the minute we try to work it out too much methods, it's just going to cause too much confusion in the class, right? So let me just stick to one method, call it a day. So I did the same thing. I throw across the positive to get a negative. I am going to use rule number 2, which says that if we minus in 2 logs with the same base, we can divide. So we're going to get log 4. You have the x squared plus 8x here minus 1 divided by x minus 1 is equal to 2. Right? I trust everyone has that at least. So what you're going to do now, right, is convert it to normal form. 4 to the power 2 is equal to this, well, jumble here. So 4 to the power 2, which is 16, because 4 squared is 16, is x squared plus 8x minus 1 divided by x minus 1. Okay? So we know 4 squared is 16. You can change it to 16 and cross multiply. Cross multiply this diagonal first and do the dashed one after if you want your working to look just like mine. Okay. So I hope you reach up to there. If you haven't, right? Right. Usually when I solve a quadratic, I don't use the factorization method, right? I believe I showed you all the quadratic formula, right? To me, that's always faster in my head. I hate the factor answers. All right. So, well, the 4 squared is 16, right? So anything multiplied by 1 is itself 16 by x is 16x. 16 by minus 1 is minus 16. Throw everybody on the same side, right? Throw everybody on the same side. You're going to get x squared plus 8x plus 1 minus 16x plus 16. And we do what? Our best to simplify it, right? X squared, 8x minus 16x is minus 8x. 1 plus 16. This correct, guys? I made some mistakes earlier. That looking correct? Hope it correct. Something looking wrong there. I think I probably did something wrong. Oh, it looking correct. Let me know, guys. Just like you, I just make mistakes once. I must make a mistake once in a while, right? Oh. All right. So some people said I did it wrong. Just now, just now. All right. I saw my mistake. It's supposed to be what over here, not positive 1. It's supposed to be -1. That's my mistake. It has a -1 and I changed it to positive 1. Right. So when we simplify this now, we're going to get plus 15. That's the correct one there. That's the correct one there. So let's see. 1, 8 minus 15. I get in my 2, 1. And this is what everybody was sending me, right? So x is 5 or, well, and x is 3, which is what the majority of the class was sending me. 5 and 3 is the final answer. Right? Now, if it, you see how it is, right? Sometimes you're doing a question and you're just tired, like you know what to do, and you just make a silly, silly mistake, right? It happens to everybody. But the most important thing, right, is that you keep trying. And guys, you see, I have no problem with people getting it wrong once they're trying the best on that end, right? So I notice a few people are just not responding in class, right? That's want to let you know that's a terrible way of doing maths or any subject, right? A lot of people think that if they watch me do a question and they take down everything after, that is learning. That is only 50% of learning. You need to work it out or try it on your own first. So let's go, right? Oh, so this one is where the class votes. Let's see the instructions here. I like these here. This is my favorite part, when the whole class have to take a vote. Let's take a class poll. Color with the highest amount of members gets 8 extra gems. And also, the color with the least amount of members gets 8. So that's kind of cool, right? So those with the most amount of members get 8. Those with the least gets 4. Everybody else in between gets nothing. All right, so let's take the poll. Let's take the poll. It is team colors. Right. Begin to vote, guys. Begin to vote. Let's see what you have to choose your team color, obviously. Let's hope your team is either the most popular or the least popular. Right? Take a 10 seconds again, right? Get your votes in, get your votes in. Let me see. Closing off the polls, and actually people are now voting. All right, you're going to be kind of surprised which one is the most popular one here. So let me end the poll and I'm going to share the results. The most popular team, there is a tie for the most popular. So yeah, I just real up. So yellow, green, and black tie for first place. So everybody in yellow, green, and black get 8 extra gems. And ironically, there's a tie for last place. Red and blue tie for last place. So red and blue get 4 gems each. Right? Yeah, this is real coincidence here. This is real. All right, somebody up to 14 gems. 2 people up to 14 gems. Hey, Zaria, nice of you to finally join us in class. Nice of you to finally join us. All right, great. Okay, this question here. Which rule you think you're going to have to use? Which rule? This one's going to be real easy, right? Which rule? I just want to make sure you're right track. I'm not really working it out, right? So like I said, that 2, we could throw it over here. Where's that different color? That 2, we could throw it over there, and we won't need it over here. So in a case like this now, you have x minus 3 squared, right? And of course, it's exactly 1 log on each side, and the bases are the same. The base is 4, so whap, like going. So you're going to get x plus 17 is equal to x minus 3 squared. Be careful, and guys, x minus 3 squared does not mean you square everyone in the brackets. Remember, x minus 3 squared means x minus 3 multiplied by another x minus 3. And you will get a quadratic, right? You will, and then you solve the quadratic again. It seems like a lot of these questions just boil down to quadratics. If you have a rec here, right? Guys, send in your answers, right? Don't, guys, please don't send something like, I have an answer. I want to see your answers. Anybody can type, I have an answer. I want to see your answers, right? Come on, guys, come on, guys. Think a little bit more before. Think on it a little bit more, right? If I need to see your answers, right? So Jared, send your answers, right? I need to make sure you're working it. All right, so let's go here. So x minus 3 squared is the same thing as x minus 3 multiplied by x minus 3. X by x is x squared. Well, I'm not going to go through basic things like this. We know how to do things. We're supposed to be up to this point in time. How much people have up to there? Right? Minus 6x plus 9. And you either have a choice, right? It's either you throw this, the x and the 17 on that side, or you throw everyone else on the other side. I personally like my x squareds to always be positive. Now, it doesn't matter which side you throw everyone else on, right? You're going to get the same exact answer. But I hate it when my x squared becomes negative. I like my x squared to be positive. So I throw in across positive x to get what? Minus x minus 17. And if we do that, we're going to get x squared, that's now minus 7x, 9 minus 17. Does my quadratic look correct? I hope I'm correct. Once again, I do make mistakes from time to time. All right. It's none of these answers. It's none, it's none, it's none, it's none. Right? All of those answers are wrong, right? It's supposed to be 8 and minus 1. It's 8 and minus 1 for x. Right? Right? Good. Right? All right. I was trying to trick somebody, somebody I suspect wasn't doing my work now. I'm only stealing the answers I put now. So I was trying to get them now, but they didn't take the bait. I was unable to confirm if they were actually doing work or not. I'll try some more tricks on them later. All right. So let's move on, right? Take a 10 seconds for those who didn't get the answer as all right. So let's see what's going on here. The team here by this crazy swamp here. So what you have to do is choose any number from 1 to 9. 1 and 9 is included. Choose one number. And if your number appears in those circles, well, that's good fortune. You get 5 extra gems to suit your one. Remember, 1 and 9 is included. You only get one number though, only one. All right, let's see if you guys got lucky there. I think most people were able to get in a value. All right, let's go. First value, 1. If anybody chose 1, you get 5 extra gems, right? So if you're on team red, I'm just saying you get 5. Well, for whichever team you're on. The second value is 6. And the next one, let's see if we get lucky, guys. Last is 8. 1, 6, and 8 were the lucky values. Don't worry, guys. If no one didn't get a value, look on the bush on the right hand side. Something is going to pop up. You all see that goblin there? He just found this in the forest. 1 black, 1 green, and 1 blue. So I hope that helps some of you all out. Right? Somebody on 15 gems, right? So Amy and Chanel on 15 gems. Anybody else? Mackenzie, 20 gems? What? People are going to accuse you now. A lot of summer grapes in class. Javon, 18. Vishala, 16. Rialine, Ramilin, 15. Chantel, Ashana, only 5. All right. Let's go, guys. Let's go. All right. So I want to show you all a special situation here in logs, like a real useful thing about logs. So let's just say, right, I have 2 to the power x is equal to 2 to the power 5. Real simple. I know it seems like I'm trying to trick you. In that question, if I ask you to solve for x, make a guess. What is the value for x if I solve for x? It's almost a no-brainer, right? Obviously, no teacher is going to give you an easy question like this, so just to prove a point. Right. Because if you have a 2 on this side and a 2 also on this side in the same exact positions, it's common sense to say 2 is equal to 2. And since the x and the 5 are both powers are in the same position, the x is equal to 5. You can even say that the 2 and the 2 would cancel out to give you x is equal to what? 5. Okay? So let's try something a little bit harder. If I have 2 to the power x is equal to 16, how much would x be in this question? This is like a form 3 maths question or a form 2 maths question. Right? Navi, no, you're overthinking it, Navi. Oh, unless you do the question already. Oh, I get confused. Navi, stick to the question that I want. You're confused, man. And it's supposed to be 4. And how would your teacher show you to do this in school? He would say you have 2 to the power x here. And he would say, hey, 16, did you know that 16 is 2 to the power 4? And he would teach you that, right? That 2 to the power 4 is 16. So now you got a 2 and a 2. You got them to look equal on this side. So the 2 and the 2 will cancel out to give you x is equal to 4. But even if I change the question to something slightly harder, let me say I had 3 to the power 4x is equal to 27. What would be the value of x in this particular question? 3 to the power 4x is equal to 27. Solve for x using your form 2 theory or your form 3 theory. How to go about this? You see, in all of these questions, we're trying to get both of them to have the same big number. Like if you have a big 2 on this side, you want a big 2. You want the bases to be the same. So you would have to say, well, 3 to the power 4x and 27, your teacher would have said, hey, did you know that 27 is the same thing as 3 to the power 3? So you notice you get the bases to look exactly the same. So the 3 and the 3 will cancel out, and you'll be left with 4x. So let's continue working here. You'll be left with 4x is equal to 3. So when you solve for x, you're going to get 3/4. Because you throw across a multiply, you get a divide. But you realize that this only is doable if you can get the bases to be exactly the same. Now, you already think maths is going to be like that in every single question, you're going to be able to get the bases to be the same? And the answer is no. So what do you do? Well, luckily somebody invented logs, okay? Your calculator, by default, can only handle, remember, log to the base 10. I think I mentioned that last week, that when you press the log button, or even if you press the LG button on your card. In fact, LG in maths means that the base is automatically 10. Whenever you see LG and they don't have the letter O, right? LG means the base is automatically 10. That's an abbreviation, right? So, but the point is, your calculator could only handle, by default, log to the base 10. So let's go to the question at hand. The examiner wants you to find, I'm going to write it back here, 3x is equal to 5. There's no way we could express 5 as base 3 to the power something. There's no way, I guarantee you. You could try to replace 5 with 3 to the power something and you will never be able to do it. This is where logs comes in. Remember, there's a concept in maths. Whatever you do to one side of an equation, you could do anything in the world. Huh? Just make sure and do the same thing to the other side. How much of y'all came across that in maths? That should have been done in Form 3, the ending of Form 3 when you were doing like advanced algebra or something like that, right? So the rule, the general rule in maths, whatever you do to one side, do anything in the world. If you want to paint it red, add 3, multiply it by a gazillion, you can do anything you want. Just make sure and be fair and do the same thing to the other side. So if I decide for some crazy reason to log this side to the base 10, I'm allowed to do that, right? If I want. I just have to make sure and do the same thing to the other side. And nobody can tell you anything. Everyone take down up to there. Log both sides. And you notice I chose log to the base 10 because I might as well choose something that my calculator could handle. Right? Remember, the aim of the question is to solve for x. Keep your eye on rule 3. Let me box this off here. Keep your eye on rule 3. So we want to solve for x. So that means we could take x and throw it over here. If we throw that x over there, we get x in front now, multiply. Well, obviously there's you don't have to write the multiply. I guess the multiply is understood. Take down up to there. Using rule 3, we were able to throw the power in front. So we kind of isolate the x now. So we want to solve for x. So now it's going to be super easy to get x on one side and everyone else on the other side. This whole thing here is a multiply. Throw it across. You get what? A divide. Finish the question there. To solve for x, you just have to take log 5. Sorry, log 3. Sorry, I mean, so it's be log 5 here, and we threw across log 3. My mistake. Wait. Finish the question. To solve for x, just press log 5. Remember, the 10 will be understood on your calculator. Just press log 5 divided by log 3, and you will solve for x. Go to 2 decimal places, and you're finished. Right, let me try. Log 5 divided by log 3. Right? Always try your best to go to 2 decimal places, and you're welcome to go to 3 to show off in the exam. And I'm seeing this on my calculator. 1.46, right? You can round it off however you want, right? But 1.46 or 1.465, the 3 decimal places, right? Once you've seen it on the calculator, and that's it. That's the end of the question. So you see how useful logs can be? Sometimes it just seems like almost impossible to solve for x. But using the concept of logs, you bypass that problem. Right? Thank God for the person who invented logs. right? Try this one now, right? It's almost the same concept, right? You need to solve for x. My advice is it's to log both sides. On this. So I think it's obvious that you're going to have to log both sides. So let's log both sides. Log 5, 3x plus 2 to the base 10. Now, if I log this side, not a problem. I just have to log the other side. What's going to happen here, right? Using rule 3, remember, this whole thing is the power, and this whole thing is the power. So I'm going to have to throw this in front, and I'm going to have to throw this in front. But when you throw it in front, how the power has more than one items, I would really suggest you put it in brackets. How much people at least had up to there? They made the step to throw the power in front, but you couldn't forget the brackets. If you forgot that brackets in this particular question, you won't get the correct answer because the power has more than one component in it, right? So this question, you can't like directly solve for x, right? It's going to be a little harder to get all the x's on one side. So here's what I suggest. Find log 5 on your calculator and round it off to 2 decimal places. Find log 7 on your calculator and round it off to 2 decimal places. At least do that. And we go replace the log 5 and replace the log 7 with those decimals. Log 5. I'm getting that's the one. I need to save some space here, right? So it's going to erase it, right? When I log this, I'm going to get to 2 decimal places 0.70 or 0.7. How much people could agree with that? Because remember we said I was going to 2 decimal places. You was getting 0.698, right? So if you round it off properly, well, you're going to get that. So I'm going to leave it at 0.7. There's no need to put the 0. Log 7. I'm getting to 2 decimal places. Log 7, 0.85. Here's what you need to do now. Multiply everyone in the brackets. Remember, the 0.7 is outside. Multiply everyone in the brackets by 0.7, and then multiply everyone in the brackets by 0.85. And then solve for x. Get all the x's on one side and everyone else on the other side. It's a regular boring maths question now, right? When you solve for x, that will be the end of that question. Right here. 3x by 0.7, I think that is 2.1x plus 2 by 0.7, and that's easy, that's 1.4. 6x by 0.85, I think that's 5.1x minus 1 by 0.85 is 0.85. Those values look okay. I think those are correct. I think I double checked them. Should be okay. And it's just a matter of getting all the x's on one side and, well, everyone else on the other side. So let's do that. 5.1x, throw him on that side. Positive 4, throw him on the other side. So I have a little switch there. 22.1x minus 5.1x is equal to minus point. That's not right that bad. Minus 0.85, that's this guy. Throw across positive, you get a negative. 2.1 minus 5.1, I'm getting minus 3x here. And on the other side, 0.85 minus 1.4. I don't know if I double check about working, I can always make mistakes. Not seeing any mistakes so far. On this side, I'm getting minus 2.25. This minus 3 is a multiply, right? Just double checking. All right. I just continue my work in here. So you get minus 2.25 divided by minus 3. But that minus 3 is a multiply, right? Here I get in 0.75 or 3/4 exact, right? Right. If the real people got it, real people got it. I was doubting it. I was literally doubting the answer, but it turned out to be 3/4. Right. So here's how this one works. It have 3 trees. The entire class is going to have to vote whether we choose the left tree, the middle tree, or the right tree. Right? So and the most popular vote, that's the only tree we are going to visit. Okay? Let's go. It's either left, right, or middle. Let's see. For some reason, it's not allowing me to. Oh, I have to close the other one. That's not right. Sorry. All right. Vote, guys. I choose one. It's either the left, middle, or right. All right. Seems that everyone has their votes in. Oh, it's a slight win. So apparently, sharing the results, the right tree won. So we are going to visit only the right tree, and let's see what gems the right tree has. So the right tree, oh god, the people who are on the blue team, well, things were really good for them. So that's why we're not going to be too happy about this, right? So give me a total of how much gems you have. The other trees don't matter because we're only going with the right tree. So far, the highest in class is somebody is supposed to at least have 21. At least one person supposed to have 21. 15 is pretty popular. 16 is popular, right? Mackenzie, you have 20 gems. Peyton, 17. Vishala, 16. I know I missed a few people. All right, guys. So thank you for playing the game. And of course, thank you for coming to class today. I'll see some of you all tomorrow for chemistry and organic chemistry. It will be. Take care, guys. Have a good one.